Imagine for a second that you are traveling through deep space. You're zooming past glowing nebulae, vibrant galaxies, just, hundreds of millions of light years of this beautiful cosmic web. And then suddenly, you just hit an absolute wall.
Right, just total emptiness.
Exactly. No bright stars, no galaxies, just this endless, terrifying dark. I mean, if you took the Milky Way, our entire solar system, every star you can see in the night sky, and you dropped it right in the exact center of this dark zone, humanity wouldn't have even known other galaxies existed until the 1960s.
Oh, easily. We would have spent our entire recorded history believing we were just completely alone in a pitch-black universe.
It's just wild to think about. And today, on the Deep Dive, that is exactly what we are exploring. It's called the Boötes Void, or sometimes the Great Nothing. We're pulling from this fascinating piece today called The Enigma of the Boötes Void, and our mission here is really to just comprehend the unimaginable scale of this emptiness.
Yeah, and it's a daunting task.
It really is. We're going to investigate the cosmic mystery of all its missing matter, and then get into the wild theories, both the natural ones and the highly unnatural ones, that attempt to explain how a pocket of nothingness this huge even came to be.
And I think it's important to set the tone right away, because this isn't science fiction. This is a real, physically mapped region of our universe.
Yeah.
And its mere existence fundamentally challenges our baseline expectations of how the cosmos is actually structured.
Right, because we expect space to be full of stuff.
Exactly. I mean, it's mostly empty space, but you expect a sprawling web of matter on a grand scale.
Yeah.
So finding the Boötes Void, it's really like mapping the ocean floor and suddenly finding a trench that just totally defies the basic physics of geology.
Okay, let's unpack this, because to really understand why this void threw the entire astronomical community into such a panic, we have to talk about just how massive it is.
It's staggering.
It is. I mean, we're talking about a diameter of 330 million light years across. And this is classified as one of the largest known voids in the entire cosmos. It was discovered back in 1981, I think, by an astronomer named Robert Kirshner.
Yeah, Kirshner and his team.
Right. And to help you grasp the scale here, think about it like this. Imagine you are driving across an entire continent. You expect to find, sprawling cities, little towns, highways connecting everything. But instead, you just hit a completely barren, flat desert with absolutely nothing on the horizon for days and days on end.
What's fascinating here is that sheer, almost incomprehensible scale of a 330 million light-year diameter. Because like you said, the universe is usually a very busy, vibrant place. It looks like a massive glowing neural network with these dense filaments of dark matter holding galaxies together.
Right, the cosmic web.
Exactly, the cosmic web. And between those filaments, you naturally do have voids. Empty spaces are normal. But a normal cosmic void might be, say, 30 to maybe 100 million light years across. So the existence of this pure, endless cosmic darkness spanning 330 million light years, ever since its discovery in 1981, it's just been a major structural anomaly.
It really breaks the mathematical model.
Completely breaks them. It forces astronomers to wonder if our baseline assumptions about the universe are just entirely flawed.
Which naturally leads us to the math problem, right? Because if the space is that big, what should actually be living inside of it?
Right. The missing matter.
Yeah. According to modern cosmological models, a region this incredibly massive should hold roughly 2,000 galaxies.
2,000, and that's a conservative estimate.
Wow, 2,000 galaxies. But in reality, astronomers have only located around 60. Just 60 isolated galaxies scattered inside this massive hole.
It is a catastrophic absence of matter.
Here's where it gets really interesting, though, because you have to think about the philosophical impact of that. Going back to that Milky Way analogy, imagine if humanity had evolved on a planet in one of those 60 scattered galaxies. We would have looked up at the night sky for our entire human history and seen absolute darkness beyond our own immediate stars.
We wouldn't have any neighbors to look at.
None. We would have believed we were entirely alone in the universe until the invention of advanced radio telescopes in the 1960s. I mean, imagine the cultural and scientific shock of thinking you are the only thing that exists and then suddenly realizing you're just marooned in a gigantic ocean of nothing.
This raises an important question, actually. It really shows how our physical placement in the universe shapes our entire understanding of reality, because we live in a very dense part of the cosmic web. We have neighboring galaxies like Andromeda close by.
We can literally see it.
Exactly. Early astronomers could see them and realize the true scale of the universe early on. But the profound isolation of those 60 scattered galaxies in the Boötes Void, I mean, they are floating like incredibly distant islands in a 330 million light-year ocean. They are missing the 1,940 neighbors they should theoretically have.
It's honestly kind of spooky.
It really is.
So with the math laid bare like that, thousands of galaxies basically just missing, we have to talk about how this massive hole actually formed. Because something had to clear that space out.
Right, the mechanisms behind it. And the source material presents two main theories here. One is a mainstream natural evolution theory, and the other is, well, it's a bit more unsettling.
The theoretical astrophysics one. Yeah, let's start with the mainstream one first. The natural theory is that smaller cosmic voids basically merged together over billions of years, right?
That's the consensus, yes.
So what does this all mean? The text mentions that gravity pulled matter away over billions of years. But I guess my clarifying question is, how exactly does gravity pull away matter on a scale of 330 million light years? Because gravity pulls things in, doesn't it?
It does, and it's a great question. You have to think about it as a tension between two cosmic forces, gravity and dark energy.
Okay, like a tug of war.
Exactly like a tug of war. Dark energy is driving the expansion of the universe. It's stretching the actual fabric of space. But gravity operates on the matter inside that space. So over billions of years, slightly denser regions of the early universe had a stronger gravitational pull.
So they start vacuuming up all the matter around them.
Precisely. They pull galaxies toward themselves, building up the dense walls of the cosmic web. And as they do that, they evacuate the spaces in between.
Okay, I see.
So imagine a cluster of smaller, normal-sized voids. Gravity is pulling the galaxies that separate them toward the denser outer edges. Eventually, those dividing walls of galaxies just thin out and collapse.
So the smaller voids basically pop together like soap bubbles.
Exactly like soap bubbles merging into one massive bubble. And all the while, dark energy is still stretching the underlying space, making that new merged void even larger.
Okay, that makes a lot of mechanical sense. Just a slow, relentless gravitational clearing over billions of years. But our source material takes a huge, hard left turn here.
It certainly does.
Yeah. It brings up a theory from theoretical astrophysicists about a runaway Type 3 Kardashev alien civilization. The idea is that they are harvesting the energy of entire galaxies and essentially extinguishing their light behind a massive cosmic shroud.
Which takes us straight into the realm of astrobiology and the absolute limits of technology.
Right, because a Type 3 civilization on the Kardashev scale isn't just utilizing a planet's energy or even a single star's energy. They command the energy of an entire host galaxy.
Yes, we're talking about a civilization acting essentially as a force of nature. To do that, they would likely use something called Dyson swarms.
Those megastructures that encapsulate a star, right?
Right, millions of solar collectors orbiting a star to capture 100% of its energy output.
So it's not like they are throwing a literal physical blanket over a whole galaxy. It's more like, okay, imagine throwing an unimaginably massive blackout tarp over thousands of entire cities, just secretly draining their power grids. Every single street lamp gets covered by a high-efficiency solar panel.
If we connect this to the bigger picture, that analogy is perfect. The city, or in this, the galaxy is still there. It's still functioning and generating massive power. But from the outside, no visible light escapes. It just looks completely blacked out.
That is terrifying.
It's a chilling implication, absolutely. It's an invasive species model on a cosmic scale. They use self-replicating probes to spread from star to star, galaxy to galaxy, just blanketing everything in these energy harvesting structures.
But wait, wouldn't we be able to detect that? I mean, the laws of thermodynamics still have to apply. If you have 2,000 galaxies entirely encapsulated by Dyson swarms, that has to generate an insane amount of waste heat, right?
It absolutely would. Thermodynamics demands that all that captured energy eventually radiates out as waste heat. So those Dyson swarms would emit massive amounts of infrared radiation.
So astronomers should be looking for a giant, glowing infrared heat signature in the middle of the void.
And they have looked. Infrared surveys haven't found any conclusive data suggesting a massive artificial heat signature there, which is why mainstream science leans very heavily toward the natural gravity merging theory.
Right, because gravity doesn't require us to invent a terrifying galactic empire.
Exactly. But the fact that astrophysicists even entertain the Type 3 Kardashev theory shows just how baffling this anomaly really is. When you are missing over 97% of the expected matter in a region, scientific rigor demands that you test every theoretical limit.
Even the creepy ones.
Especially the creepy ones.
Well, it really brings it all back home for you as the listener. I mean, whether the Boötes Void is just this natural gravitational anomaly that formed over billions of years, or an eerie, totally unnatural monument to cosmic evolution, it just serves as this chilling reminder of how empty the universe can truly be.
It really challenges all our assumptions about the cosmos.
It does. It completely shatters the idea of a uniformly busy universe.
Hmm.
But before we wrap up this deep dive, there was something in the source material that really stuck with me.
Ah,
We talked so much about the missing galaxies, but what about the 60 that are still in there?
and survivors.
Yeah, I mean, think about the psychological reality for whatever might be living in those 60 isolated galaxies.
It's a profound thing to consider. Because regardless of how the Great Nothing formed, whether it was relentless gravity slowly pulling their neighbors away, or an expanding cosmic shroud systematically darkening the galaxies around them, the end result is exactly the same for those 60 systems.
They are just stranded.
Completely stranded in a 330 million light-year ocean of black. And it leaves you with this final lingering thought. If you are an inhabitant of one of those isolated galaxies, and you are looking out into your night sky watching the darkness encroach, knowing you are entirely alone, what do you think is waiting for you in the dark?
Man, that is just such an unsettling note to end on. But it's fascinating to wrap your head around. Thanks for joining us on this deep dive into the Boötes Void. Catch you all next time.